Hello everyone, this is a lecture which is based on waste heat recovery. This is the last part of unit number 2 of the subject emerging trends in mechanical engineering. In short, we will learn again what are the waste heat recovery devices. Let us see one by one. In introduction, let us see what is the given thing. Many industries and their processes utilize large quantities of fuel and electricity that ultimately produce heat for a process and generate large amount of exhaust heat, much of which is wasted and simply pass out the stacks into the atmosphere or local rivers and stream. When energy is abundant and cheap, users tend to pay little attention to this waste. But during periods of high energy cost, industrial processors need to focus on these losses and implement strategies to utilize the waste heat and reduce their energy consumption. The basic technique of waste heat recovery is to capture the waste heat streams and utilizing a heat exchanger, transfer that heat to another medium to be put back into the process. The many advantages to the industrial processor are that waste heat recovery can reduce a facility's annual fuel bills, reduce plant emissions, and improve the productivity. In process heating, using waste heat will displace a portion of the fuel or electricity that would otherwise be purchased. Waste heat recovery is always a good idea when the temperature of the waste is hotter than the input requirement of the process. Number 2, the fuel savings achieved are greater than the capital and operational cost of waste heat recovery equipment. Temperature determines waste heat. The value of the waste heat stream is determined primarily by its temperature. It is widely held that any waste heat stream of at least 260 degrees centigrade or 500 degrees Fahrenheit is a viable source for recovery. Obviously, the higher the temperature, the higher the quality or value of the waste heat. So what are the sources of waste heat? Here you will see combustion exhaust, process exhaust, hot gases from drying steam, drying ovens, and cooling tower water. So these are the sources of waste heat. Recovery technologies that are used equipments, regenerator, recuperator, economizer, waste heat boiler, thermoelectric generator. And last one is end use for recovered heat is preheating in boiler feed water, raw materials, combustion air, electricity supply, and domestic hot water. Classification of waste heat: high grade heat above 300 degrees centigrade and low grade heat below 300 degrees centigrade. High grade waste heat is in the form of flue gases and can be readily recovered through heat transfer equipments, while low grade heat is in the form of process steam and rainwater commonly found in many of the industrial plants like food processing and chemical industries. These are the sources of waste heat: heat in the flue gases, heat in the vapor streams, convective and radiatant heat losses, heat loss in cooling water, heat losses in providing chilled water or in the disposal of chilled water. The waste heat sources are glass melting furnace, cement kiln, fume incinerator, aluminum reverberatory furnace, boiler, process of gases, steel electric arc furnace, aluminum reverberatory furnace, cooling water from furnace, air compressor, internal combustion engines, conductive, convective and radiative losses from equipment, and conductive like hall air cooled cells, and hot cokes and blast furnace. They are used for hot waste heat, combustion air preheating, boiler feed water preheating, load preheating, power generation. So these are the some of the uses for waste heat. Another that we have seen in power plant, cogeneration or combined heat and power, is defined as the sequential generation of two different forms of useful energy from a single primary source, typically a mechanical energy and thermal energy. Mechanical energy may be used either to drive alternator for producing electricity or rotating equipment such as motor, compressor, pump or fan for delivering various services. Thermal energy can be used either for direct process applications or for indirectly producing steam, hot water, hot air for dryer or chilled water for process heating. Cogenerations are of two types, topping cycle and bottoming cycle. Topping cycle, what is happening? Primary heat is used for electricity, waste heat is used for secondary power heating or power applications, and in bottoming cycle, primary heat used for directly for process requirements and waste heat is used for produce electricity. Trigeneration means process by which electricity, heat and cold are produced simultaneously. So this figure is indicating you trigeneration. Fuel is given to the power system, it is producing electric power here. Then there is a heat recovery which is used in cooling, refrigeration as well as for heating. So trigeneration, heating, cooling and electric power. This is a Trident generation diagram. Fuel which is supplied to engine turbine, then it is connected to generator, it is producing electricity. This waste it is given to heat recovery unit, then further it is utilized in steam or hot water to be cooled, in hot water for AC circuit. Then there is absorber chiller. This chilled water is given to the buildings. Electricity is also provided to the building and grid, like this. Recuperators. Let us see the different equipments that are used in waste heat recovery. One number is recuperator. Next is regenerator. Next is heat pipe exchanger. Next is thermal wheel or rotary heat exchanger. Next is economizer. Next is heat pumps and run around coil. You can stop this PPT and read all the information related to every devices. These are the applications of waste heat recovered. Preheating combustion air for boilers, ovens and furnaces. Preheating fresh air used to ventilate the building. Hot water generation including preheating boiler feed water. Direct steam generation for process or power generation. Space heating and drying. Special applications of waste heat are animal shelters, aquacultural uses, greenhouses, agricultural uses and process heating. What are the benefits? There are certain direct benefits and indirect benefits. Recovery of waste heat has a direct effect on efficiencies of the process. This is reflected by reduction in the utility, consumption and cost and process cost. Indirect benefits include reduction in pollution, reduction in equipment sizes, reduction in auxiliary energy consumption. These are the references. You can go and refer these links for more studies.